Hello everyone. Uh, this is M. Venkatramana doing masters under Computer Aided Structural Engineering 2022 in Mahindra University, Hyderabad. And a part of this program is a course, Infrastructural Health Monitoring, and taught by Professor Visalakshi Talakokula. And coming to our course project, now I'm gonna demonstrate my course project, which is about fracture energy studies of carbonated induced corroded beams using polypropylene fiber reinforced concrete. So quickly jumping into the introduction, I would say polypropylene fibers, my choice to take polypropylene fibers was their uh, behavior in enhancing ductility properties and crack resistance and resistance to freeze and thaw. Many enhanced properties are found by their usage in recent trend if we see. And also it is seen that ductility of FRC depends on the ability of the fibers to bridge cracks, which helps in resisting overall crack propagation and initiation as well. And it also increases the strength by lowering the permeability of concrete with high modulus of elasticity. As of now, there are three different forms of fibers are available, and researchers have found that the good practice when it comes to polypropylene fibers was found to be using 3% as highest percentage to replace by overall cementitious material in a M30 grade concrete or above. So my objective is to calculate the fracture energy and mouth opening of crack using of beams casted with polypropylene fiber reinforced concrete. And abstract goes like this. We have seen a recent trend where in past recent years polypropylene fibers haven't gained any much importance, but in recent years it has gained so much importance and applicability due to its enhanced properties shown in concrete. And coming to my work, I'd be morely focusing on fracture energy under different loading by casting a number of samples, which I went with M30 grade, and fibers I took were 13 size, uh, with a volume fraction of 0.2% of replacement of total cementitious material, and all the specimens casted were undergone 28 days of curing, uh, and results are spoken furtherly in next slides. So this is how polypropylene fibers look. Their texture are so fragile, and these are short fibers basically, which are 13 in size. But when you see the picture, this is how they bond the crack. This is how they enhance the compression and tension. So next slide. And before going to the original mix, I went for a trial mix, which of M30 grade, and I casted three number of cubes of 150 and 150 and 150 with a 0.42 water to cement ratio and M sand as fine aggregate and CBS based polycarboxylate superplasticizer, and as we know 0.2% of maximum polypropylene fibers of total cementitious material used. So here are the quantities, volume of uh, concrete, and this is the total batch weight for the trial mix. And after the mix, I've performed a slump cone test, which I almost got 120 value of the slump, and then some images of polypropylene fiber in real and some all other materials used for casting. And then this is some few pictures and video of how casting was done in drum mixer and put it in molds. And then coming to the original mix, I went for casting of 7 beams and 3 cylinders as such. And again, repetitively showing this is the mix design, mix proportions, and total batch weight for 7 beams overall. And again, saying 0.42 is a water to cement ratio, used M sand as fine aggregate, polycarboxylate superplasticizer, and 0.2% of polypropylene fibers. And I went with ACC super grade as cement And again, 120 as slump value for the original mix also, but this time I've used a bigger mixer to cast 7 beams, as it was a big proportion. So you can see in the image that a few polypropylene fibers spilling out to get the easy mix. Initially, it was thought it was a raw mix, but simultaneously, uh, over the time, we got a very good slump value and smooth finishing as well. And then these are few images before, uh, after pouring into concrete and after demolding. As you can see them, 3 cylinders, extra volume, put it in a cube, and remaining 7 beams casted. And then beams kept in curing tank for almost 28 days in the curing tank. So I had to cast a total 13, including original and trial mix. So one beam extra, and 3 beams for flexural test purely, and 3 cubes casted for compression, 3 cylinders casted for split tensile. And this is how, apart from casting, I had bonded a sensor. This is what we call a piezo sensor. This is a 10 square patch. This is a bare PZT image, and then I've bonded coaxial wires to its negative and positive terminal. As we can see, a small portion over here and a bigger portion. I've bonded the coaxial. I've soldered the coaxial wires to the PZT patch, and then you can see taking this PZT patch, and I've bonded this to the beam top surface, using epoxy and resin. In epoxy and resin, and after that I had to take free PZT reading. This is the LCR meter setup. This is the system that contains vPro software and which is connected to LCR meter. So I mean to say that other end of these coaxial wires, which are one end bonded to the piezo sensor, which is attached to beam, and other end of these coaxial wires are connected to LCR meter using crocodile wires. And this is how the interface of vPro software, and we here can save the file and set the desired frequency and interval, and then run. It takes free PZT reading by providing electricity to piezo sensor. And uh, priorly, I have to say that at various stages have taken this signature using the vPro software. That is free PZT reading. I just have said that means the reading of bare PZT, and then bonded PZT signature bonded to beam, and then PZT signature after providing a notch. I'd be showing the image of notch provided to beam. And the reason why I'm taking signature at this stage is giving notch with a concrete cutter is also a damage inducing to the beam. So 4 levels basically, I would say: a free PZT, bonded PZT, signature while providing after providing the notch, and then signatures while I'm applying a flexure load. So I have divided the ultimate load into 5 or 6 parts, and incremental load has been given to beam. Whereas at each kilonewton, I'd be holding the load and then taking the reading. So as you can see, this is the output data given by taken out from the LCR meter. Basically, we get Excel sheets out of it when we are done with taking reading, and then plotting them on the basis of x-axis as frequency and y-axis as conductance. These are the baseline signatures I have acquired, and I have said I've casted 6 beams and divided them into 3 parts, each part containing 2 beams. That means set 1, set 2, set 3. And the denomination I've given here as baseline of B1S1. That means baseline of first beam in set 1. So as such, I have bonded sensor to only 3 beams, which means 1 beam in 1 set. Other 3 beams are not provided with the sensor to perform a comparative analysis as such, to bring out both the fracture energy from the beams which have bonded the sensor, and mouth opening of crack from the beams which have not bonded the sensor. And these are the images. You can see other 2 sets which are kept in carbonation tank for accelerated corrosion. As my title said, I would be carrying out a comparative analysis of these three sets of beams where I test beams at their fresh state, I mean flexure test at their fresh state for first set, and then for set 2 I'd be testing for 20 days of carbonation. I mean these beams would be put in carbonation for 20 days and then taken out, tested for the flexure, and then 36 days of carbonation as such. So you can see this is how beams are put in carbonation after PZT is bonded on their surface successfully. And this is how I provided the notch of 25 mm. This is just like a groove I've put with a concrete cutter, which is 10 mm wide, and 25 mm deep. Based on notch depth ratio, I've taken it, and 3-point loading as a flexure test I have given, where you can see piezo sensor is somewhere here realistically. So coming to the results, this is the output data that LCR meter gave me. As you can see, only barely you can see 2 lines, but there are 4 signatures embedded in it. One is 3 kilonewton, the blue one, orange one indicates 9 kilonewton, 12 kilonewton and 15 kilonewton. That means readings were taken at these load values. So how beam behaves is sensed by the piezo sensor serially at these intervals. This is the conductance signature, which is a plot of frequency and conductance, and then few images at the flexural load equipment. This is the notch as I've already shown, and this is the 3-point loading image. And these two are first set of beams where one is bonded with a sensor and another one is not. So after breaking, we have got the values as I've just shown this plot. This is the output data we are getting. And regarding output values of cubes and cylinders, these are load values I'm getting for 3 beams, for specimen 1, 2, and 3, as I've casted 3 beams, as I said. At 490 kilonewton, I've seen hairline cracks on the surface, whereas at 400 kilonewton, I've seen the at 760 kilonewton, I've seen the distribution of those cracks below the neutral axis depth, and final failure reaching the cracks reaching the bottom surface. I mean total depth is at 1029 kilonewton, and these are other 2 set of values for specimen 2 and 3, and these are split and Zell values below of 3 cylinders I have casted, 175, 247, and 160 kilonewton respectively. These are ultimate load values where cylinders got completely broken under tension. So these are some images where this is just before loading, where load started to apply on the cube, and these are the hairline cracks, a small hairline crack you can see, and this is a total failure pattern as we can see, and few more images of cylinder before and after failing. And these are few references I've taken to study the behavior and properties of polypropylene fibers when they are used in beams and other structural elements. So this is the holistic review I could give based on my experimental values and other such work. Thank you. And also thanks my professor and my professor Visalakshi Talakokula and my mentor Ramesh for helping me and guiding me all the time. And thanks to university as well. Thank you.